Section 1. A quiet miracle. The question of autumn's colors. Have you ever stood in a quiet forest and wondered about the world around you? Every autumn across vast parts of our planet, a silent and beautiful transformation takes place. The endless green of summer gives way to a brilliant spectacle of new colors. Leaves that were once a simple, uniform green suddenly blaze in shades of gold, vibrant orange, deep, fiery red. This change happens so regularly that we can almost take it for granted. It marks the gentle transition from the warmth of summer to the cold stillness of winter. But this familiar event holds a fascinating story. A story of chemistry, of physics, and of survival. It is a tale of how trees sense the changing seasons and prepare for the months ahead. We will explore the inner workings of a leaf. To understand why leaves change color, we begin with the color that dominates most of the year: green. Section 2. The Green Factory. Why leaves are green in summer. Leaves are the kitchens of the plant world, creating food for the entire tree, from the deepest roots to the highest branches. Inside each leaf are millions of tiny cells, and within them even smaller structures. Here, the tree performs one of nature's most essential processes: photosynthesis. It is the method trees use to turn sunlight into energy. This pigment is called chlorophyll. It is what makes leaves green. Chlorophyll is exceptionally good at absorbing light, particularly red and blue wavelengths, but it does not absorb green. Instead, it reflects green light. That reflected green is what we see. During the long, sunny days of spring and summer, leaves are filled with tremendous amounts of chlorophyll. The tree produces it constantly, keeping its food factories at full capacity. Chlorophyll captures sunlight. The leaf uses that energy with water from the soil and carbon dioxide from the air to produce simple sugars. These sugars are the tree's food, powering growth, new branches, and overall health. The green is so intense because the leaf is packed with chlorophyll. Its abundance masks other pigments, like the yellows and oranges, beneath. It is like trying to hear a single violin in a room full of loud trumpets. Chlorophyll drowns out the quieter colors. This changes dramatically when the seasons begin to shift. Section 3. The Changing of the Guard. Autumn's Arrival. As summer wanes, the world begins to tilt. The days grow shorter and the nights become longer and cooler. For a tree, these are unmistakable signals. The change in daylight length, photoperiod, is the most reliable cue that winter is on its way. Trees sense that abundant food production is ending. It is time to prepare for dormancy. They conserve resources and begin to slow down operations. One of the first changes: the tree stops producing new chlorophyll. The leaf's factory begins to shut down. Chlorophyll is costly and unstable. It breaks down in sunlight and must be constantly replenished. Once production stops, the green fades. The stage is set for other colors to appear. Cooler temperatures, especially chilly nights just above freezing, accelerate chlorophyll breakdown and influence the formation of reds and purples. Shorter days and cooler nights create the perfect conditions for the transition from summer to winter-ready form. Section 4. Hidden Colors Revealed. The Science of Carotenoids. As the green of chlorophyll disappears, the first hidden colors emerge: yellows and oranges. They come from pigments called carotenoids, present all spring and summer but masked by chlorophyll. Carotenoids make brilliant yellows in aspen, birch, and hickory, and bright oranges in some maples and other species. The same pigments give carrots their orange and corn its yellow. In summer, they capture light and pass it to chlorophyll, and help protect leaves from excess sunlight, acting like a natural sunblock. Think of a painting. A thick green layer covers the canvas. As it is scraped away, yellows and oranges are revealed beneath. Because carotenoids are already present, their display is relatively consistent. As long as chlorophyll fades, yellows and oranges appear. That is why you can count on golden aspens and yellow birches year after year. The beauty we see is a revelation, not creation. hidden colors shining through as green withdraws. While the yellows and oranges are revealed, the most spectacular reds and purples are actively created. These vibrant colors come from anthocyanins. Unlike carotenoids, anthocyanins are not typically present in summer. They are manufactured in late autumn, a final, brilliant flourish. This is why the appearance of red can be dramatic, and in some years, breathtakingly intense. Their production is complex and highly dependent on weather. Triggered by sugars trapped in the leaf, bright days allow some photosynthesis even as chlorophyll breaks down. Cool nights form a special layer at the leaf base, slowing sugar export. Sugars accumulate under bright light. Warm, sunny days followed by cool, crisp nights, the recipe for spectacular reds. This is why reds in maples, sumacs, and oaks can vary so much from year to year. Cloudy days and warm nights yield a dull display. The right mix of sun and chill can set forests ablaze in crimson and magenta. The incredible diversity of autumn color is shaped by two main factors: species and seasonal weather. Each species has a genetic blueprint dictating which pigments it can produce. Aspens, carotenoids, brilliant yellow; sugar maples, carotenoids and anthocyanins, orange and red; oaks, tannins, browns and russets; pines stay green with needles. Species mix determines a forest's palette. Maple-rich regions glow red, birch and aspen regions glow gold. Weather acts like a conductor. Bright sun and cool nights amplify color. Late summer drought can brown leaves early. An early hard frost can kill leaves overnight. No two autumns are alike. The same forest can range from muted to explosive color. A unique performance shaped by sunlight, temperature, and the deep biology of trees. After colors peak, the final stage begins. The leaf falls. This is not an accident or a sign of weakness. It is deliberate and controlled. Holding broad leaves in cold, windy, snowy months would be a liability. Leaves catch wind and snow, straining branches. Leaves would also lose water when frozen ground limits replacement. At the base of the leaf stalk, a special abscission layer forms, from Latin meaning to cut off, pinching off water and sugar conduits. Cells on the twig side make a protective seal, preventing water loss and blocking disease after the leaf falls. As the connection weakens, the slightest disturbance, a gust, a raindrop, even its own weight, frees the leaf. It drifts to the ground, its work for the year complete. The tree enters dormancy, conserving energy for winter. While the colors are beautiful, the deeper purpose is survival. The tree strategically salvages valuable resources, nitrogen, phosphorus, pulling them back into twigs, branches, and trunk. Nutrients are stored safely through winter. In spring, reserves give new leaves a head start. Red anthocyanins may shield reabsorption machinery from excess light and act as antioxidants during shutdown. Carotenoids help dissipate excess light energy. Colors are functional as well as beautiful. After falling, leaves return organic matter and minerals to soil, feeding insects, fungi, and bacteria on the forest floor. Leaf litter insulates and retains moisture, sustaining a complex web of life, completing the forest's cycle. So, the next time you walk through a forest in autumn, take a moment to look closely. The brilliant colors are more than a display. They are visible signs of quiet, methodical preparation for winter. They tell a story of adaptation and survival, written in a language of light and chemistry. Each yellow leaf reveals a color hidden all summer. Each red leaf is a final, vibrant creation, fueled by sunny days and cool nights. This transformation reminds us of the intricate connections within the natural world. Trees measure day length and night chill, orchestrating a magnificent, silent symphony of color. The science is elegant. Green fades, hidden yellows and oranges appear, bright days and cool nights kindle reds. The tree lets go to endure winter, a cycle of release, renewal, preparation, and patience, awaiting the return of the sun.